Hello, welcome everyone. A lot of you probably know that I'm working on my plugin template, which is supposed to enable me to make plugins really fast. So in this video, I'm trying to make a plugin in a very short amount of time and just see where it goes. And I decided to actually emulate another plugin in this video. I'm talking about a plugin made by MDA. If you have been using VST plugins for a long time, then you probably feel nostalgic about MDA plugins, cause there are a lot of them and they have been around a lot of time ago as 32-bit plugins, and there were ones like MDA Overdrive or MDA Reap Psycho and all kinds of stuff that was pretty cool. And I want to take MDA Overdrive and bring it to the next level. Gladly, I don't have to write the code completely by myself, because Hollands, the developer Hollands, already converted a lot of these MDA plugins to a Juice project, which I have here in front of me. And yeah, in this little example, it's just a direct conversion from the old code to new code. So there are no new features added. And my goal is actually to take some of these concepts and put them a step further, so that they are actually making sense in a modern workflow. But I also want to, retain the original sound. So the original sound should be retained, but at the same time, I want everything to work really fine. And an example for that is, for example, when process block starting here, then the parameters updated at the start, and that was it. So there is no parameter smoothing in here. Also, this plugin only works on a stereo track because it always assumes that there are two channels in the buffer, which is of course not the case. So these are things that I just want to make different in my version of MDA Overdrive. And yeah, I guess let's go or something. So the first thing that I have to do when I want to make a new project with my plugin template is that I have to go to my plugin template and copy it into a new folder. Oh, actually no. Yeah, it's not that easy actually. It's a little bit more involved. So I want to make a new project, and I might call it Overdrive Renew or something like that. Cause a friend of mine said that animes always are called like that when you remaster them. So I will call this like that as well. I was thinking about also putting MDA in the name somewhere, just as a tribute, but then people could think that I am MDA, and they would be silly. I'm not MDA. So now what I actually have to do here is not copying the builds and also not the Git repository, as I really don't need it here, and also not the library code, as it can be constructed from the juicer file. Just this kind of stuff. So that didn't take as long. Now I already have my project, and I have a little info file in here where I always go to look for my to-do list, what I have to do to make my template even better, and especially how to use it when I make a new project. So the first thing that it says is copying the source and the producer file into a new folder. I did that. Now I can rename the plugin in the producer. So this project is now called Overdrive Renew, like neon lights, Neo. Okay, I think there was another place where you have to put that as well. Yeah, plugin name. For some reason there are two places where you have to put that. I have no idea why. Now the next thing is define a unique plugin ID. So plugin ID, wow, that is a very unique plugin ID we got here. So let's actually take something that is above N and above E, so that it looks a bit like new. And now configure the preprocessor definitions. Okay, so I got these preprocessor definitions here, and copying them out into a new text file. Sorry for white mode, this is just the text editor of Windows. And now I have to decide for certain things. Do I need an editor? Yes. Do I need a patch browser? Okay, fine, I have a patch browser, why not? Do I need gain in? Yes, because we're talking about distortion. Should I add oversampling? Actually not quite sure, because my oversampling is quite CPU heavy and it could make people think that everything is terrible in my plugin, but let's just say yes. Unity gain, should we have unity gain? Yeah, unity gain is the fact that when you put gain in, then you get simultaneously a drop in gain out, so that it compensates for the in-between processing, which makes a lot of sense with distortion. Now, has stereo config true? This would only make sense if there was some mid-side processing. And that actually makes me think we could add a mid-side processing thingy in there that would like make that, you know, that you can dial in a drive offset to the side channel. Let me just put a to-do list here with all the cool ideas that we get. So we want to have parameter smoothing. We want to have mono stereo or any channel count. We want to have mid-side drive offset. Okay, good. Now, can we switch the polarity on the dry signal or on the wet signal? Yeah, I think that would also make sense with drive, but we can also still change that later. So equal loudness mix. This is for the dry-wet processor, because sometimes when you have a strongly correlated signal, like in a vibrato, you need that to get a nice volume match for dry-wet. In this case, we have a filter and then distortion, and the filter is probably, yeah, the filter will probably introduce phasing, so that can drop in volume. So let us actually, yes, we want to use equal loudness mix here. So which FPS do we have on the knobs? 30, yeah, okay. On the meters, 30, okay. The text editor, fine. Value bubble, I don't know if I still use that actually. I should check that sometime. Now, meters use RMS false. Yeah, fine, whatever. And some input defaults that I should care about a little bit later. Or maybe even already, because we are sort of talking about distortion. It might make sense to go really high with these so that people can get crazy. And for the gain out, since we already have automatic gain matching on the gain in, the gain out doesn't have to be so crazy. And if unity gain exists, then its default is true. That makes sense. Now debugging, no. And pitch shifter is currently not used. So yeah, these are the settings that I use now. And now we should be able to run this thing. Let's close the editor. I'm listening to trance music, that's why I'm in my head. You might ask if I'm listening to trance music when I'm making a guitar effect. The reason is when I oh wait, can I even talk about building? Because sometimes it messes with my audio in the OBS. I should not talk while building, which is a shame because I really like doing something in old waiting time. Great. Okay, so what I wanted to say earlier is when I used MDA overdrive, I always put that after autotune, because then it makes vocals sound like e-guitars, and then you can say something like and it comes out like the craziest guitar solo ever, and that's just what I'm currently missing. Now, this is the UI currently. And yeah, maybe I should change the default settings for the bounce and also for the colors, because I actually enjoy color scheme like this a little bit more. But yeah, apart from that, it seems to all work pretty well. Now we have overdrive reneo and it looks very nice. And we can actually start working. So my first idea here would be to actually go into the audio folder of things and add a new header file. And this is going to be the overdrive reneo header. Reneo. Yeah. Later I will split that to header and CPP, of course, so that everything builds very fast. But I really like to start with just writing headers, because it's kind of a better workflow from a coding perspective, in my opinion. So now we go to the shared code of the plugin and to the reneo thingy. What was it? Overdrive reneo. I should actually make a distinction between just some audio and DSP kind of classes, because this folder is getting pretty big. But I will not do that now, as I'm currently testing how fast I can actually reach a goal. Overdrive reneo. Okay, so this is where all the magic's going to be. And now I will turn down the trance music a little bit so I can focus. So we want overdrive reneo to be a class that has some constructor. It has a prepare method. I don't know yet for what I will need it, but I will probably need it because there is definitely you know, a filter in there, so filters need sample rate. And then there is also the buffer with the samples, with the number of channels and the number of samples. And I already know that this is going to be no except, because this is going to be fast and this is to be yes except, and yeah, I guess that's like the basics what we need here. So our overdrive reneo, actually we can already put the sample rate in here, because we already know that we will need it. And maybe we could even put block size in here, because we might want to make some lookup tables. Yeah. Okay, so now I have to go to my processor and actually make sure that renew is part of this thing. Overdrive. Great. Now, what's next? Oh yeah, I have two classes in here, the processor backend, which just has the boring stuff, and the normal processor, and the normal processor is where you can put your stuff. Overdrive. And yeah, now I made a little overdrive thingy, and I can finally instantiate it. And now I can go to prepare to play. Where is it? It might look a little bit messy because of all these preprocessor definitions, but the preprocessor definitions are the reason why I can define the whole project with my config file. So I think it's pretty cool and powerful. It doesn't hold me back a lot. Just it makes it slightly harder to read, but for a huge speed gain, so that's cool. So now we have the dry wet mix, the meters, and of course the overdrive, which we will be preparing, but not with the normal sample rate, but with the upsampled sample rate, in case that we are using the oversampler sometimes. So great. Now we have our overdrive prepared, and we can go to the process block custom method, where I always put my custom DSP. There is also some other processing block like dry wet and stuff, but that's not interesting. So I made a method just for the stuff that is different from each plugin to plugin. And that's where I now put the overdrive with the samples, the channels, and the num samples. And you can already see, looks pretty much like my overdrive processing block now. And probably not a lot more will happen in here. Just I will have to add parameters at some point. Yeah, but apart from that, this is sort of it. Now we have to actually go and implement what the overdrive is doing. And now we have to deal with someone else's code. So what does Hollands write? Hollands made an audio processor with input and output, it's stereo, a listener for the APVTS state. I don't know why. I'm not so much into parameter listeners. A lot of stuff. La 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 la. Now we have something interesting in here. We have reset state. So let's just take this and also add it to our overdrive. It's going to be private. We want to keep all the things out of the way that are not really needed on first glance. And this already implies that we have a filter L variable that is a float, and a filter R variable as well. And that already shows me the first thing that I want to do different, which is including array, so that I can make an array of these. Now I can I can just clear all filters. What? Why? Oh yeah. Okay, sets the filter delay units back to 0. So I don't know yet what the delay units are, but I have a method now that can set them back to 0, and I already know that this is going to be a no except one, because why would this throw an exception? Now The next thing I'm gonna steal from this code is the update method. So let's see what this does. It has a drive parameter and it gets the drive with a percentage value. So we actually want a normalized value here. So instead of having this in here, I will actually just add more arguments to this method and say that this is a drive P for parameter, and I will make a little note in here that says I want a normalized parameter so that I can remember that. And yeah, now I can go into this update method with my drive parameter, which is 0 to 1 by default. Now I don't need this anymore and can instead just see where was drive used in here. Actually, was it used? I think it was not, so I can actually completely keep it out of this function call. Now what else is in here? The muffle parameter controls a low pass filter. Muffle is percentage converted to a value between 1 and some number that drops off exponentially. 1 means the filter is disabled. The smaller the value, the lower the cutoff frequency will be. At 100%, the cutoff is around 200 Hz somewhere. Since it's a first order filter, it has a gentle roll off at 6 dB per octave. Okay, so this is also a function, this is also a parameter and a muffle parameter. Muffle. Nice name for a filter. That makes it very descriptive instead of technical. Now what is this range? It's in percentage. Okay. Okay, I don't want to mess with percentages too much when it's going to be such a weird formula. So let me just also input this as a percentage here. And then I will just take this code and put it here instead. Now, obviously, this looks a little bit useless here. Instead, just putting this here directly. And this is going to some value called filled. I will call it filter so that it fits to my other change. And I will just take this comment and also put it here so that I remember what this all means and maybe make a change later. Actually, I could make this change already and give it a normalized value in here. Take this out. Should do the exact same thing now as it does in the original plugin. And I can set it const except if it changes later. Now this is already not needed anymore, which is pretty cool. The output level is between -20 and 20 decibels. Convert to linear gain. So there is an output gain control. Yeah, I already have an output gain control in my high level part of the plugin, and it is definitely between 20 and it's 24, so pretty close to that. So maybe we can just scrap this function entirely. And yeah, so currently this is just what happens at the start of the process block call. Now we have process block itself, scoped denormals, clearing buffers, we already did that. Expected true, where is this used? Okay, this is some weird parameter listener thing. So we can also scrap that. Now this is the stuff that is interesting actually. Let's just copy that completely in here and just you know, go with the flow. Now the first thing that I see is we have in 1, into, out 1, out 2. Let's just comment that out so we can still see what it was. But instead, we're just saying samples get array of right pointers. Oopsie. Oh, we don't even need to do that because I already had samples in here. But just so you know why this is more useful than getting a lot of pointers from an audio buffer. In Juice, every time you call one of these audio buffer points, there is an atomic operation in it that checks if the buffer currently is clear or not, or something like that. And that is just a feature no one actually needs. So it's always very beneficial if you only get the samples once in the plugin, per buffer call, I mean, and then just use that. So now drive, we already have our drive parameter. Currently, we're just copying it directly in here. And then we have gain, which is not needed. We have the filter coefficient, which is going into F. We can probably get rid of all this kind of stuff later, but I'll just keep it here for now. Let's see where we actually use in and out. Okay, I can already replace this. I like my brackets to be like that. Now I want to have the value S for this. It's just one of the things that I always do because it stands for samples. I call these kind of things S then. FA and FB times gain. Okay, so we don't use gain here, so boom. Now for channel. Now we actually have the channel loop in here, and we can say there are samples just for this channel. Now we don't need the ins and outs anymore. So let's get back from that. So let's pretend like essentially this is just the same, that we just have this. And A was the current sample. So we just say sample is samples as. So minus sample plus sample sample. Now let's see, what does this actually say? It says if the sample is bigger than 0, then skirt sample, and else minus skirt sample. I actually want to know what that looks like. So let's try that. So we have a normal signal like this. And then, okay, cool. X is bigger than 0, in which case skirt X, and else minus skirt minus X. Oh wow. That's a nice little wave shaper we got here. I can see how that is a cool thing. Let's see, fx equals. And now we can go in there with different functions, like having a sine function. And now this is the wave shaped sine function. Yeah, nice. And then maybe a drive parameter. Okay, it is a wave shaper that definitely just makes things very loud when going in there with drive. At least I'm doing something, if I'm not doing something wrong. Not sure. It's not like a 10H one that just gets... Well, maybe that's the reason why we cannot go in there with drive at this point yet. The drive's down here. So also take this away. Now we already have our drive parameter. And AA was this. But actually now I just saw we have to make a differentiation between A and AA. So let's bring AA back. Or let's rename it sample B. Okay, now we can actually make something interesting here. Yeah. That looks a little bit cleaner to me. Now what was FA? FA is this value. And interestingly, FA already existed before because it was this. Okay, it is the current filter that is being used. But still, I need to clean up some of this mess before I go on. For example, the drive parameter, it really doesn't need to have its own coefficient when it's just directly used the way it is. Can just do this then. And then filter, which is F. It's currently a little bit misleading that I'm renaming this thing all the time. So let's just do this. And then this is always the filter of a certain channel, so it has to be moved in here. Channel. And yeah. Now it didn't like that for some reason. Filter of channel. Why not? Filter of channel. Huh? Oh, that's because I used the same name for these thingies. Okay, I cannot do that. So let's instead call this muffle, as it's like what happens to the muffle parameter. Now this is going to be, well, just F, I guess, or even filled, yeah, or filter without I. Okay, things are getting a little bit weird now, but anyway. Okay, it still doesn't like something here, which is the fact that I'm using the wrong name here. Okay, now I can remove this comment as it's just about the channel stuff that I'm not using anymore. A simple exponentially weighted moving average filter. Okay. When F. Yeah, cool, I guess. Now, this is not out anymore, but samples of S is filter. No, filter. Now I'm just wondering what's the place where I'm putting a new value into filter that's down here after all the loops. And that of course doesn't work cause oh, that's only for catching the normals. Okay, then I guess I don't need it. No, my problem is just that this thing is never updated again. So I seem to have missed something. Otherwise it would make no sense. So let's go back and actually look at my mistake. Boom, 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 boom. What do we have here? This is FA and FB, and the thing that was missing here is filled L, filled R, which is probably a member variable. Yeah, it has to be. So where is this call from reset state? Prepare to play calls reset state, and then parameters changed. And reset calls reset state. Okay, so this is a prepare to play thing. So instead of having the reset function that is obviously only for prepare to play, I just have it in prepare to play itself. And at some point I will have to tweak this filter to actually take the sample rate into account. This is also going to be on the to-do list of things. Maybe I could also just plug in completely new filters, but I want to stick to the original for now. So now, did I give a... Okay, so now I have a default value for filter, which for some reason still claims to be non-existent. Maybe now? Visual Studio acting up again. Okay, so we got our prepare function ready. And yeah, let's just get rid of all of the comments for now, because if I wanted to read them, I could also go to the GitHub repo anyway. Now I have a better overview about everything. Okay, so we still don't have our filter thingy improved. But I think if I was to do this, yeah, then that would just override the buffer at the end. And I think I can actually replace this with a plus equals. Yeah, that will make sense. But that's kind of crazy, because it's like we are adding something to the filter coefficient all the time, and it's still not gaining volume constantly. I mean, okay, there's also a minus in here, but whatever this wave shaper does, it's kind of crazy and I don't quite get it. It's some mathematical magic, I guess. Or I made a mistake. So we have to find out what it is. First of all, we need a drive parameter and a muffle parameter. So let's just go to the parameters. I can also already start Bitwig. Now this is my parameters header and CPP file. This is my ID, and I always put all the parameters in here. So I will now put in here muffle and drive. Now it's going into the CPP file where I have to define some stuff about these parameters, like that they exist as something that has a name and what that name is. Come on. Considering that the drive knob is a different knob than the input gain, it might be a little bit confusing, to be honest. Why does it not find muffle and drive though? Come on, muffle, drive, now, please. Okay, maybe it's just Visual Studio doing weird stuff again. No, actually, it's kind of suspicious. Why does it not find it? Makes no sense. PID muffle. What is this again? Anyway, I'm pretty sure it works. It's just weird. So essentially a low pass filter. Lol. I will have to put better text in there sometime. Driving the signal. Hopefully. No, actually, what was my mistake here? I did write commatas. Huh? There is no mistake. Well, let's go on. So now we can skip a bunch of stuff. Actually, no. So this is my parameter. Oh, actually, we can skip the parameter stuff. We only need to go into the parameter vectors, which is params. Now, and then we can add the parameters, muffle and drive. Now, currently, let's just set muffle to 1, because that was told to be the default state when nothing happens, and drive to, I don't know, 0.2 or something. And since we are not using percentages yet, let's just make a very conservative normal parameter now that it has no skewing. Okay, we can mess with this a little bit later. Now, of course, I still want to know why this doesn't work, because it's it makes no sense. But let's just run this application now. Let's see how many I'm in. 2. Okay, that's a good time for making full. Getting myself something to drink, and then I'm back. Okay, so I'm back, and I found out that something broke, and I'm very curious what it is now. Crush gain is not a thing. Oh yeah, of course, we are in the UI on the low level UI container now, where we have to explain that muffle is the thing and that drive is the thing, and muffle has the name muffle in it, and drive has the name drive in it. Also, I will have to rename the parameters in general. Muffle and drive. Muffle and drive. Yeah. Muffle and drive. We don't need a spline editor. Spline editor is not done anyway, so would make no sense to have it in here, and has no function in here. I just had it in here for debugging. Muffle and drive. No spline. Okay, so init. The init function wants to know where are the parameters, a little bit of space, a parameter of this size, and then this, and then this. And this is just the same, but with less stuff. So we are moving into the 1 direction. 1 and 2. Boom, boom, boom. Okay, looks good. Let's see if this runs. Oh, we still got something bad going on. Audio processor backend, illegal member initialization. Okay, I put this on the wrong place apparently. That explains why it looked so weird before. Actually, so let's go down here to wherever the processor backend ends and the other processor starts. See, it's here. And then I can also make this look normal finally. All right. Yeah, I already know what this is. We have to put in the parameters here. So we have the muffle parameter. Get val mod denorm. Okay. So if you're asking yourself what is val denorm and what is val mod denorm, actually we don't need denorm in here because we're using normalized ranges, which is pretty cool. I always like when that is the case. Okay, so this is my parameter helper, and you can get the value in normalized fashion when there is no denorm in it, or just with denormalization, and also with or without modulation on it. And of course, in process block, it makes sense to always get it with the modulation on it, because then you can use the macro functionalities with it, which make my plugins special, hopefully, and hopefully also cool. Now let's run this. Okay, sweet. Some stuff is happening and it's not crashing when I'm moving the knobs, which is a good sign, I guess. And it looks good. Cool. Now let's actually compile this to VST-3. Okay, so if you were asking yourself what I just did, I just prepared some samples. And now this is going to be the Overdrive Re-Neo test project. Now I have to turn off the trance music that I'm listening to and actually start listening to my plugin and these samples. Okay, now this is going to be exciting. Ooh. Oopsie. Something is going wrong in here. A lot of things actually. So I think the first thing is that for some reason, wait, I have to adjust some of my settings here. So for some reason, overdrive, I think I put these in the wrong order. Let's see. Drive, muff. Yeah, that's the wrong order. Okay, so that is the first thing that didn't work very well. And the second thing is, oh, now it finally works. So it only doesn't work on the first open. Yeah, cause it seems like the modulation is locked by default in here, even though the button for locking it is here. Only then it should be locked, and then it should act like a normal macro. So so that is a problem. And yeah, that will also be part of the video now, because as I said, I wanted to test how easy it is to use my plugin template to actually build a plugin, and if going with a completely new plugin in there results in the plugin not working correctly, then I need to fix that before going on, and only then I can really say that it took a specific amount of time. We're currently 50 minutes in, and around 50 minutes, and I think it's still a pretty good time for making a whole plugin. So I can just easily go in there and tweak some stuff and still have a good time. This is sort of a speed run. Yeah. Okay, so what was it? It was locking the parameters. So where is it? It is in the parameter stuff. Okay, so I've got parameter stuff in here, and the locking is in the, not in the param class, but in the params class. There is mod depth locked, and I suppose mod depth locked is true by default. No, it is false. Okay, so what does it actually make true? This is load patch middle. If there is already a mod depth locked in there, then null pointer. If there is no mod depth locked information, and else set mod depth locked is the dereferenced value of that being not 0. So this is either true or false. This seems to make sense to me. So there has to be a different place where things go wrong. Maybe it's on the UI side of things. Maybe it actually does the right thing, but it's just painting wrong. So in order to find out that, we have to go to the UI and actually ask ourselves what happens. Okay, so I have to remember where was the actual place where these things are decided. Let me think. It's on the knobs. So I guess it is on the knob creation side of things, which would make sense because I recently rewrote some stuff there to be more modular, and there's always a bit of a possibility that things go wrong when you do that. Now this is the free function that makes a knob a parameter. And now let me quickly look at this. Renew. So it always happens when a plugin has been opened the first time. So it's like a state thing, and it acts on how the parameter is painted. So there should be some sort of locked property in here. Somewhere in this huge function call. Max mod depth, mod bias meter, blah blah blah. Mod dial. Where is the locking thing? Yeah, so we have a locked parameter in our knob and it's false by default. But it's a different type of locked. It's like mod depth. What we are searching for, not locking the parameter entirely. But still, maybe I wrote something a little bit wrong. Okay, so let's see. What is this? If there is a meter and the parameter is locked, if I mean the locked state changes, then update the locked state. Yeah, that makes sense. That's not the locked state that I mean. This is the locked state that I mean. Lock, unlock, parameter values are locked into place even when changing presets. No, that's also not the locked place that I mean. Okay, that's, I don't know, that's kind of weird. Or maybe the parameters themselves also have an information about whether or not the mod depth should be locked. Where was that function? I actually wrote it today. A new function in here. Calc var mod off. No, that's not for locking the modulation depth. I should look in the header actually. That's what headers are for, whether a certain thing exists or not. I still need to get into the workflow of using headers. Locked and engaged. That's a different kind of locked in here. Oh, mod depth locked. Yeah. So what is the default value of mod depth locked? It is true. So that is the problem. It needs to be false. When the plugin is instantiated new, the first assumption is that there is no mod depth locked. Okay, so we got this fixed. And yeah, now we can run this thing again. Okay, I think it succeeded. I just accidentally tried to run it, which of course makes no sense.
slow down here if you wait, 'cause it's changing fast and then the second wait. My words are basically a rising day as I lay them down onto the track. People in the past try to oversample it, but they couldn't figure it out like quantum entanglement. So they just drove me harder than ever before. At the point of no return, they say why not?
Now let's actually check if strongly correlated is the right thing here. Let's just take these drums. First of all, let's turn off the elastic algorithms so that we get sort of a clean signal. So now we need to gain match. So yeah, I think it's definitely a little bit too loud on 50%. So we can go into our producer and turn off the equal loudness mix. It's definitely not much of a thing in here. Save the producer again, go back in here, reload, and build again. Okay, great. By the way, one thing, or two things, I just added something to my to-do list, which is auto gain for filter and drive. And I already solved the mono stereo thing. Let's actually put the to-do list into the file of our overdrive so that we don't have to look at this ugly editor anymore. And now that we have compiled this again, we can try it. I'm actually not sure if I really need input gain in this plugin, cause I mean, in some way it's a distortion plugin, but it has a drive knob, and the input gain is, no matter if unity gain is on or off, it just seems weird. Like when it's off, then it just seems to make things louder without adding more drive, and when it's on, then it just randomly makes things quieter. So let's also get rid of the gain. Has gain in, false, no gain. Okay, great. But before compiling it again, let's just see if we can do anything else here. Now, let's try the polarity stuff. Okay, the polarity stuff does make a difference. It seems to have a very weird workflow. But I think I will just keep it in there because some people like weird stuff. Now, yeah. Okay, great. Yeah. Let's check it out. Oh, still the same? Why? I thought I turned off gain in. Yeah, I did. Still the same. Okay, so there is a problem with my project reacting to my changes in the high level editor. Where is high level? Alright, or maybe it's also in the header. So let's see. PPD has gain in is defined on 1, but it's not true. Here it says has gain in false. So why does it say 1 in here? Do I have to put both of these to false so that it works? That would be weird. Come on. Show me what you got. Has gain in. There is no typo in this. PPD has gain in. It's here. It says false. Does it have to say 0 to be explicit enough? Would you be so kind and update? Come on. What? Okay, so that doesn't seem to be the issue, so I can keep the word false in here, but why does it just not like my PPD changes at all anymore? I am on the Overdrive Renew project, and I can also just add start it again, no problem. It's just weird because you never have to do that usually. But does it at least work? It does not. And why does it not work? I mean, the other PPDs also work, so why does it not work? PPD has gain in. Okay, let me also check on some other place. It doesn't seem to be in the high level editor anyway, the problem. Gain in is also used in the processor. And there is also the issue in here. Okay. So I guess I have to do that. I have to put that on my to-do list again as well. Okay, so apparently there is some stuff that will like exceed the length of this video. Because this video is not going to be about bug fixing entirely, it was just about how quick it is to make a project running. The project is already running. But now the next question is, how long it takes to actually make something cool with it. Something that is a bit more next level. And one of the things that are currently not very next level are the facts that there's no parameter smoothing on the muffle. So let's actually add that. Include architecture smooth. Now I added my smooth header that has the so-called smooth files. And yeah, now I just have a smooth called muffled instead of a value. Or actually, I made another class that is more straightforward for this kind of stuff. It is in the PRM header. Yeah, PRM. And I think I even called it PRM. Let's see, did I? Yeah. So I have a parameter muffled, and this is a special type of parameter because it has parameter smoothing in it. So muffled 0 is the default. And now I can just say muffled prepare, sample rate, block size, and length in milliseconds, which could be maybe 20 milliseconds makes sense. This is how long it takes to smoothen the parameter. Now we have a muffle value in here. And what we're doing now is we're saying muffled, muffling the muffle value for num samples of size, and then we got the muffle buff out of it. And now we have a parameter that is smoothened, and we can use the muffle buff in here. So now we have smooth parameter changes on muffle, and we can do the same with the drive. Let's just say drive also has a default value of 0 and also a speed of 20 milliseconds. And then currently we use drive here, but now we will make a drive buff instead with driving the drive p by num samples. And now drive buff in here, and boom, we have all of our parameters being smoothened. And yeah, let's just test how that feels now by running this again. Great. Yeah. Great. So I'm not entirely sure if I was missing the parameter smoothing in the beginning, but it's definitely there now, so that's cool. Yeah. So there is one thing that I just thought would make sense. Not only a filter that is dependent on sample rate, like most filters, for obvious reasons, but also higher order filters would be cool. And maybe a drive that goes a little bit higher, because I always feel like this is a very, even 100% is kind of conservative for a huge distortion plugin. And I somehow feel like it was different back then. It was like more driving. I'm not sure if it's true, probably not. Maybe my nostalgia is just messing with me. But let's still just try what happens if we go to the processor, and or let's still go in with the normalized value and actually handle that in here. Drive p times, let's do it times 4 and just see where it goes, if it's cool or not. Yeah. All right, let's go. Yeah, I think 400% makes more sense. Let's see if oversampling actually makes a difference. Yeah, sounded a little bit different.
You don't have to wait, 'cause it's getting faster than the second rate. My words are basically a rising back as I lay them down onto the track. People in the past try to oversample them, but they couldn't figure it out like quantum entanglement. So they just drove them harder than ever before. At the point of no return, they still right now. You want some juicy lines, you don't have to wait, 'cause it's getting fast.
Okay, cool. Let's get rid of all the modulation stuff again. Oh, actually, that is good. I should get into my own workflow stuff, because I recently just made this feature where one can remove all modulations with one button click, which is very useful, I guess.
You want some juicy lines, you don't have to wait, 'cause it's getting faster than the second rate.
Now I just noticed when you turn up the drive a lot, then it would make sense to have a gate before, or an expander maybe. Like if I did this.
You want some juicy lines, you don't have to wait, 'cause it's getting faster than the second rate. My words are basically a rising back as I lay them down onto the track. People in the past try to oversample, but they couldn't figure it out like quantum entanglement. So they just drove them harder than ever before. At the point of no return, they still right now.
Okay, it seems to be very hard to do something against the drive. So maybe I should not plan to add my own expander in there, as I'm already trusting FabFilter more to make a really great expander, at least until now. Okay, so
You want some juicy lines, you don't have to wait, 'cause it's getting faster than the second rate. My words are basically a rising back as I.
but now that I changed this, I actually want the 50% mark to be more close to the original 100%. So I have to figure out a new parameter skewing. Or maybe it doesn't have to be exactly 50%, but something that sounds a bit more reasonable. Because it's going for the higher drives so fast, and I want this to be able to replicate some subtle saturation as well, because that's just a thing nowadays with distortion. And what I'm doing here, I need to go to my params, and there we have the with center method, which currently is on 0.5, but now we want the center to be a much lower value. And yeah, this should now give us something more reasonable to work with. But I'm currently not sure, will that also mess with the way it is drawn on the screen? Let's see. Yeah, so we have 12% in the center now, 50% up here, and then it goes a little bit coarse at the end, but you can hold shift to move it sensitively if you really need that. Now we just have to find out how it feels. Or maybe let's do that later, because we will check that out anyway when we are running this thing again. So Now we can, let's just keep this open for now. Go to our to-do list again. We have parameter smoothing in here. Now what's the next easiest thing that we could add? It's the mid-side drive offset. So let's just make one of these. Parameter. What is this? What do we call that? Side drive side offset. Oh, I need to find a better name for that, but not now. Good. Great. Now what? Drive side. Okay. So what do we do here? Let's just say we're doing -1 with the center of 0. So yeah, that could make sense. Now drive off, drive side off P, and this can be a value between -1 and 1. Drive can actually be between, yeah, it's also -0 and 1 actually. And so what will I do with this now? I need to act differently for each channel. But if this also needs parameter smoothing, then I should check if there is mid-side in it at all, because otherwise it will be less performant. Except if people also want to have different sides for left and right. Is that a thing? Left more gain, more drive than right. Yeah, I guess some people are creative like that. So let's actually just do that. We need a second drive math. So basically like this. What? Why? Hello? Why does it not like this? for D and drive D prepare. Why not? Okay, anyway. Okay, so I always have either 1 or 2 channels. So I can just say, instead of having that in here, I can put that into my channel loop. And say, drive of channel does this. And then I have to add the offset, but first of all I want to find out why it doesn't like my array. Oh, because it's a float array. It's getting late. So, do your thing. Great. Now I need to add the offset. And yeah. Oh, this expression is going to be a little bit too long for my taste. But let's just make it like this. There is a drive value. And it might be that there is a drive side offset P. But it depends on the existence of a second channel. And then the result is being multiplied by 4. And now I'm actually not sure if I have to make sure that this is always a positive value or not. It might not matter. Otherwise I will have to use JLimit also. But I think we could already try this and just see where it goes. But just looking at this very closely in order to find out if there is anything else I might forgot about. No. Do I send a parameter value there? No, I do not. Now this time I have to actually send the denormalized one. Oh, here as well, because I changed, you know, the skewing. And yeah. And now I can actually add the parameter to my low level knobs. Hammy. Miau. Ey, du willst gar nicht raus bei dem Regen. Okay, next line. I think this should be it. Let's see. Cut. Ja, Katze. Okay, so let's go. Maybe I should not call it side offset if it also works right. But I just feel like most of the functionality is in mid mid-side, or it really makes sense, an offset that does not change the balance. Because usually when people change the balance of things, they try to stick to volume. What? Okay, I made some mistake. Let's see. We have two things left, right. Oops. That must have been it. Katze. 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 Oh, that was fast.
You want some juicy lines, you don't have to wait. Cause I'm speaking faster than the sound you wait. My words are basically a rising bat as I lay them down onto the track. People in the past try to oversample, but they couldn't figure out the quantum entanglement. So they just drove them harder than ever before. Let the brain fall return, the sunlight.
Okay, cool. I really liked how that sounds. Both on left, right, as well as mid-side, but it sort of did something different than I thought. Instead of being a drive side offset, this just seems to be some sort of stereo width in general. That would describe it even better and would also look much better in the UI. So I just take this time now to rename it. Channel offset to the drive. Ja, that would describe it. Ja, Emi, ganz toll. Ich lass dich gleich raus, aber lass es doch erstmal ein bisschen regnen. Ja. Ja. And now I want to also change something about the range, because it sort of felt like it did the same when I went to left and right. So let's only go to the right and also add the same skewing here so that we have more precision on the low values. And yeah, so now that we have figured this out, we can go here and say mid-side drive offset is solved. And now I can let my cat out. No. Okay, so the next thing that I want to do is actually caring about the auto gain stuff, and I have a very nice method for that. But the code that I wrote in that contains the auto gain module, I made it commercially for someone, and of course I can just take some things out and just put them into a new context without it being against the license or something. But I should not put the whole code in general into this video. So let me just quickly pause this video and come back when I only have the auto gain grabbed out of it. Alright, so I'm back and copied my auto gain stuff out of the other project, and now I just have to tweak it so that it works for like more general cases. For example, here I have num gain steps and num gain steps f and a bunch of assumptions in here. And I think I will just keep only the stuff that I really need in here. For example, I should definitely include array, because I'm dealing with arrays. Okay, great. Then there is the Bayesian twister, which is in random. And I already have a using for the audio buffer. I don't need these sort of props. I don't need identifier in here. Now this thing sort of implies that you go into it with some sort of class. So let's just ignore that for now and only do the things that we actually have available in here. So no diffuser. Let's just get rid of it completely. So the gain array, it is the array. Gain array is an array of num gain steps plus 2. So let's just make the gain steps actually a parameter of auto gain instead of being, you know, static, so that we can have a little bit more control over that kind of stuff. So what do we have now? We have the gain array, and instead of making this an array, we're now making it a float, because this is now dynamic. And we have noise, which is for some reason not in the initializer list yet. And the noise array, it has actually uses. Okay, so we also want to give it a size, probably. Noise size to be more precise. And yeah. Okay, great. Now we can resize the arrays. Noise resize to noise size. Actually, this can be reserved instead of resized. And the gain array, that will just be also reserved. Num gain steps. And then num gain. Oh, actually, no. I can resize it directly to 1 because I would put 1 in it anyway in this loop. Great. So synthesize white noise is the next thing that happens in here. And what it does is it procedurally generates white noise with a Mersenne twister and random distribution between -1 and 1. So it's sort of generating an audio signal into the noise. Now noise size is not something that exists anymore. Gain array is not something that exists anymore. So what we're doing now is using noise size as a member variable. So this is now a thing, now pinken noise. That is when we take the white noise and make it pink noise with this cryptic looking formula that sort of works for some reason. And yeah, now we have created pink noise. And now the prepare method, what does it do? It has an identifier, but this doesn't seem to be very much the thing that should be handled by the auto gain. I think it was more of a rush decision to write all that down. So I don't know if I need a prepare method in here anyway, but it might be that I do. So let's just keep it there. Now what does the operator do? It should pick up some buffer of samples and the num samples, and then the noise array should be a vector of floats. Oh cool, just like the gain array. So now for each sample a bunch of weird stuff happens. Oh yeah, that is linear interpolation, I see. So what is this? Diffuser macro buff. That kind of makes no sense. That is an assumption from the other project. But at least we have num gain steps f. And yeah, well the problem now is we need to access this parameter because the auto gain depends on where the parameters are in the plugin. And I have to come up with a solution for that, and once I have come up with a solution, I will put it into this code, and then it can be used to apply auto gain. I'm just thinking, should I do that now, because this video is already heading towards the 2 hours mark and no one is going to watch a video that is so long just to see me struggling. But I can still, you know, at least get these things right here. For example, here get noise RMS. There's no need to have it look like this. All right, great. So what was size? Oh yeah, the noise size. Make auto gain values. So noise RMS, get noise RMS from noise data. Then the actual effect must prepare itself, and then there needs to be an audio buffer. Here I thought I had renamed this thing. I did not. Actually, it's in the audio utils, I think. Yeah. I have to import my audio utils here. Does it also have array? No. Okay, so we have a juice audio buffer with only one channel from 1 to noise size and temporary gain array, num gain steps f. Basically, we are calculating RMS from our noise, and then we're comparing it with the noise processed through our effect, and then we get the ratio between all these RMSs for different parameter values, and then say, okay, this ratio is the gain parameter, you know. So this is where we would update the parameter, and then we would run the process again on the noise. Then we get new RMS value, as you can see, and then we, well, in the case of the other plugin that I had, one had to clear it. And this process only has to happen once to just check what are the different combinations of parameters that have to be accounted for. And then it is never been touched again, but only the operator. That's like the point of this class. The problem is, as you can see, it is not very generalized. It was written specifically for a specific thing, and I need to find a way to make this a little bit more modular so that I can plug it in anywhere, and that would be such a big thing that it would even require its own video. It makes no sense to just have that in here and force you to watch 2 hours of me trying to make a plugin, only so that after these 2 hours something exciting happens again when no one can concentrate anymore. Let's just run this code really quickly again, one last time. No, actually as a VST3 plugin, of course. That's kind of interesting now, because when you have it set up like this, drive on 0 and then with something, then it will sound very huge. But if you dial it back to mono, then it still sounds like very not normal. No change at all. And maybe I should actually take the time and make this a correctly working panning module, so that if used in left-right mode, it can be used to dial to the left side as well as the right side. So that I should really keep that in mind, or make a little to-do list for that. Auto gain stuff, and also not with, but panning. What else is there to say?
Juicy lines, you don't have to wait. You want some juicy lines, you don't have to wait. Cause I'm speeding faster than the second rate. My words are basically a rising bat as I lay them down onto the track. People in the past try to oversample them, but they couldn't figure out like quantum entanglement. So they just drove them harder than ever before. At the point of no return, they still right more. You want some juicy lines, you don't have to wait. Cause I'm speeding faster than the second rate. My words are basically a rising bat as I lay them down onto the track. People in the past try to oversample them, but they couldn't figure out like quantum entanglement. So they just drove them harder than ever before. At the point of no return, they still right more.
Oh, I could just really hear the difference between HQ and not HQ. That was interesting. You cannot always hear the difference so clearly.
You want some juicy lines, you don't have to wait. Cause I'm speeding faster than the second rate. My words are basically a rising bat as I lay them down.
Okay, let's see. I'm already in the last minute for this being exactly 2 hours video. That's a great moment to just say goodbye to this video. I think this proved that with my plugin template I can accomplish huge stuff in a very short amount of time, even when problems occur. And of course this is still far from done, because my to-do list is just getting bigger and bigger instead of smaller. But it's just really cool that I got until this point, and I think the